This one is question number 6, November 22, paper 4-1. The figure shows particles A and B of masses 4 and 3 kg, respectively, attached to the ends of a light inextensible string that passes over a small smooth pulley. The pulley is fixed at the top of the plane, which is inclined at 30 degrees to the horizontal. A hangs freely below the pulley, and B is on the inclined plane. The string is taut, and the tension in the string between B and the pulley is parallel to a line of greatest slope of the plane. It is given that the plane is rough and the particles are in limiting equilibrium. The particles are in limiting equilibrium. The particle is at rest. The force in the weight is 40. The tension is T. The tension is same throughout this wire. Weight of the object B is 30, and these are the components of weight. Mg sine 30. This one is a normal reaction R. This component of weight is Mg cos 30. Now tension is equal to 40. Because the particle is in equilibrium, so these two forces should be equal. Tension is equal to 40 Newton. Now consider the particle B. In the particle B, the tension which is in the upward direction is 40 and the component of weight is 15. So 30 sine 30 is 15. So the body has a tendency to move up the plane. So the body has the tendency to move up the plane. As the plane is rough, friction will act downwards. Mu r. Now we will consider the particle B and equate the forces. Now, forces perpendicular to the plane. R is equal to 30 cos 30. Now the force is parallel to the plane. T is equal to 30 sine 30 plus mu r. T is 40. 30 sine 50 is 15 plus mu r is 30 cos 30. Mu is equal to 25 is equal to mu 30 cos 30. Mu is equal to 25 divided by 30 cos 30 is equal to 0.962. Now we will move to the part B. The part B is, it is given instead that the plane is smooth and the particles are released from rest when the difference in the vertical heights of the particles is 1. Initially, the distance between the vertical heights of the particles is 1. Use energy method to find the speed of the particles at the instant when the particles are at the same horizontal level. When the particles are at the same horizontal level. Suppose that this particle moves to this position and this distance is moved by the particle downwards is x, and the B particle has moved to this position. Now you can see that both the particles are at the same horizontal level. Both the particles are at the same horizontal level. Now A has moved a distance of x meter downwards. B has also moved a distance of x meter above the plane. B has also moved a distance of, जितनी ये रोप नीचे आएगी A नीचे आएगा उतने ही B ऊपर जाएगा. So this distance is x. The difference between the new and the old position of B is x. We will draw a triangle. This angle is 30 degrees because of this. Now the height obtained by this particle B. Now the height obtained by this particle B is x sine 30. Now the first equation from this information is x plus x sine 30 is equal to 1. This total height is 1. So x plus x sine 30 is equal to 1. Sine 30 is 1 by 2. X is equal to 2 by 3. Now, use energy method to find out the speed of the particles at the instant when the particles are at the same horizontal level. Consider the particle A. There is a loss of potential energy in the particle A as the height has decreased, but the velocity of the particle A has increased. So there is an increase in the kinetic energy of A. Consider the particle B. There is an increase in the height, and the height is, there is an increase in the height of the particle B. So the potential energy has increased. There is a increase in the velocity of the particle B, so there is an increase in the kinetic energy. We will use the energy method. There is no force, there is no driving force, so work done by the driving force is zero. Loss in energy is the only energy, no, is the only potential energy of A, plus M. Mass of M is 4 mgh. Height decreased is x, and x is equal to 2 by 3, is equal to, there is a gain in energy in the height of, in the speed of A, so half into m into v square is unknown, and the initial velocity is 0. There is a gain in energy, kinetic energy of B, and because both the particles are connected, so the speed of both the particles is same, half into 3 into v square minus 0 square, plus there is a gain in potential energy of the particle B, and which is equal to mg sine theta into x. M g sine 30 into height moved. Height moved is x, which is equal to 2 by 3. AT over 3 is equal to 2v square plus 1.5 v square plus 10. So 3.5 v square is equal to 80 over 3 minus 10. V is equal to 2.18 meter per second. This one is the speed of both the particles when they are at the same horizontal level. I will further elaborate this question. The law of conservation of energy is work done by the driving force, which is equal to 0, plus loss in energy there is only one loss of energy, which is in the potential energy of A, plus gain in energy. There are three gains. Gain in kinetic energy of A, plus gain in kinetic energy of B, plus gain in kinetic energy of, gain in potential energy of B. And the fourth one is plus work done against resistance. And there is no resistance in this question. So plus 0.